Hi guys, today we'll do something special, which is to take the Bitcoin Core code and modify it. So let's go. What is the Bitcoin Core? It's the reference client and the reference implementation of all aspects of the Bitcoin system. It's mostly the node, but also wallet and mining part is there. We'll focus on the node here with the plan to modify it. If you are interested in the more detailed analysis of the Bitcoin Core code, I have also written an article about it, so I will link it down below. But for today's video, our plan of action is basically to build a code base as it is on the master branch right now, to have the stable reference point. Then, having it built, we run the node in the regression test mode, which is basically running in the local network, not talking with other nodes in the Bitcoin network. We'll play with some remote procedure calls to get familiar with it, since we then will be adding our own remote procedure call command. Then after doing that, we recompile it and see that it works as intended, and even we'll write some functional tests in Python, actually, using Bitcoin's Core's test framework. And for the additional context, because we do this on my local machine, details like that matter, so my operating system and CPU architecture is here, as you can see, which is Ubuntu, I think it's pronounced, and one of the latest in the CPU. Yeah, so I think we can basically start. As usual, to make it faster, I have executed a few steps already. So I have cloned the Bitcoin repository. And I also have prepared a few dependencies, but to go over them, I have linked what's required basically. And for my operating system, we just to have cmake, core, and make, and C++ compiler, GCC. I use GCC. I think you can use Clang as well. And then later on we need to have Python interpreter, which is more or less up to date to write and run functional tests. This is that's all, which is just a few things. As you can see, the Bitcoin Core codebase itself, it has more dependencies, but we'll build them from source using Bitcoin Core's depends build system. It just takes a list of dependencies, download them from the internet, and build them locally. So maybe before doing that, we can see that we are in the Bitcoin Core repo already, as I have called it. Here we have some C++ code that we are about to modify, actually. Some cmake files, which are crucial for building and compiling the code base. We have a test directory with functional tests. We will add our own here as well. And that's mostly it for the depends custom build system. There's a different folder here. I forget to clean it, so let's clean it. It's results, and then we have packages here, which are packages specified here, which are dependencies of the Bitcoin core, and we are about to build them right now. So let's go to the terminal. Let's export this variable. We'll skip UI basically. That. This guy. And then we just need to invoke make path from the depends directory on 8 CPUs. For me, this can take a while since we need to download a few dependencies from the internet and then build them. So let's wait. Alright, so I have built the dependencies from sources themselves. Right now we can build the Bitcoin core itself, specifying the dependencies that we have built locally. One more additional thing is that, as you can see, we are skipping UI as previously, and by running this command, since it's cmake, it will be really fast. It only generates make files that are then used to compile all the source code in the right order. Alright, something went wrong. Let's see. Alright guys, I just had repo in the wrong state. I deleted too many files. So it's fine, as you can see right now. It has run with information about the build, and we already have B directory, and I think here or maybe here there are cmake files, and if you go to any of those directories there is a make file. And yeah, but we are not concerned with details like that today, but it's worth knowing that this command, it just generates make files. It can also run with other build systems, but that's how cmake works. It's some kind of meta build system that generates files for another build systems. So finally we will compile the Bitcoin core. This can take a while depending on your resources. I think for me it will take a few minutes, so let's wait. Alright guys, the code has finished compiling. It did take a while, but fortunately for our changes it will be significantly faster, since only a small subset of changed files will be recompiled. So right now we can go to the next step, which is to start the Bitcoin node locally using this regression test mode. So let's maybe go to the different terminal, go to the P directory, and let's run this command of running the Bitcoin daemon. I believe that's YT. It has started, and right now we can play with Bitcoin CLI basically. So as we have it in the README, let's run a few commands. Build directory. Let's execute Bitcoin CLI also in the regression test mode. Let's see how many blocks we have. Block count 0, obviously, as it is here. Also, if we go to the next example command, which is to get info about the blockchain, you can see that we are on the regression test network. There are no blocks, no headers. That's the minimal difficulty, because the regression network, the difficulty is 0. Size is very small, and yeah, that's more or less it. Let's now generate a wallet and let's have sent some Bitcoin to our server. So first, create a wallet. We then can generate get new address for this wallet here, and then we'll mine, because we can do this on the regression test network, since it's close to our local machine, our local network. We can generate as many blocks as we want, and the block reward will be paid to the specified by us address. So let's generate to address. Let's maybe also mine 200 blocks and use our generated address from here. And that will take a while, since we are generating 200 blocks. We get the hashes, so instead of, maybe let's run this guy and see that we have 200 blocks. Also, we can check the blockchain info. We have a lot more blocks, and the size is significantly bigger than it was for the whole blockchain. And let's similarly run those examples. We can get hash of the block 100, and by hash we can use right now this hash. We can use this hash to get info about this particular block. Yeah, it was not copy-pasted. I didn't copy-paste the whole thing. So as you can see, we have block. It has that many confirmations because it was over 100 blocks ago. It's a block 100, height, version, yeah, and some other data. So yeah, this is how remote procedure commands work, more or less. We have Bitcoin CLI. Underneath the hood, it just makes HTTP requests as specified in the remote procedure calls protocol, because it is a protocol. Additionally, can show that for any of those commands you can add help parameter, and it will show you examples of the output arguments, if there are any for specific command, and usually also the fact that you can just run HTTP requests and get the same response, but it's more convenient to use Bitcoin CLI Office. So knowing that, we can go to the most important part, which is changing the code. So because we are about to add our own remote procedure call command, we need to follow the conventions and do a few things. So first is that we have this register h header file where all the remote procedure commands are being registered. So let's actually find it. Register h. As you can see, we have function, we have declared functions here that in turns register some subsets of commands, you can say. So let's add here our own. So we will call it magic number RPC commands. It's just declaration. We also need to because this is called somewhere in the code, as you can see, to register all the remote procedure calls command. So let's add register magic number. All right, so but that's only the declaration. Then we need to implement it somewhere, but maybe let's see that if I would try to recompile it, we should get an error because we have just declared the new remote procedure command, but there is no definition, obviously. Yeah, as you can see, a few files, and yeah, we have an error. So let's proceed to actually define it. Yeah, so let's go to the remote procedure call directory and let's create magic number file like that. We have written it here, but let's go step by step. So first we need to have a few includes for types. We need to have a function like that. I've used examples of another commands. So for example, get block count. You can see it's really similar, and we can use it as our example. But before doing that, if we remember, we actually registered a function like that. We have registered a function like that. We have declared it. So right now we should implement it here. And if I remember correctly, how we had it there. Yeah. So let's copy that because it's not that important. And there's nothing in particular interesting here. We just have an array of commands where we have a category of the command which is only used somewhere as an information. It's not really important. It's one of the known categories, and we have a pointer to a function which is here. We are about to implement, and it's really similar for all commands. So for example, if we go to the blockchain file, which is obviously used already, you can see that it's all the same. There's a different function name, but it has the same signature, different category, but also pointers to functions. And we have just one function. So let's focus on the most important thing, which is to implement our command. And as you can see, we need to return this type RPC help manual. I don't know what it means actually. Remote procedure call help something. but maybe instead of copy pasting it from the README, or let's just write it step by step. So what do we have? getMagicnumber is just a name. Yeah, I think we use this constructor, so it's just a name of the command. Then we have a description, that's a magic number. Then we have arguments, but let's go for the first version, let's go without arguments. Then we need to specify a result. So let's do let's just construct the remote procedure call result object, and for us it will be an integer number. I think it was type num. Yeah, here it was some kind of key that we are not interested in. It doesn't matter for us, and just the description of the result, which is just a magic number. Then we have some examples. One is for the CLI version, and for the context it is, maybe go with simpler commands, so get block count, for example. And the CLI example is this guy, and RPC is this guy, which is core. So yeah, it's almost the same for us in the README. We'll have finally, in the end, we'll have the same thing, but right now I want to go without the argument. Just kick this off, and this will be concatenation of R to have an array, and RPC1. We don't have an argument yet, we will have, but let's start without one. The last thing is a function. We can go to the constructor to just check it out. So yeah, here we have just a function reference, basically, more or less. So here we have the syntax for it. So we have JSON. First was the RPC help object itself. Yeah, then request, and we return uni value, which is a value, which is a type that Bitcoin Core uses for JSON types, basically, more or less. Yeah, and here we have multiplier, as you can see, but so for now let's hard code it, and let's return uni value multiplier times our magic 467, which obviously can be anything. I have just chosen, arbitrarily chosen this value. All right, let's check out whether it's fine. Request. Yeah, I think it should be should be fine. Yeah, so that's not needed, I think. Yeah. Yeah, so I think we should be able to compile it, but there is one more thing left, which is not intuitive. Not this one, but yeah, we need to add it to CMake lists, because if we go there, there is a Bitcoin node library, which is reused by a few other targets and libraries in this Bit setup. Yeah, so as you can see, it is functionality which is used by the Bitcoin daemon and Bitcoin Qt, which is UI executables. And here we have all the various files, but also the RP's remote procedure calls. And I believe that register, maybe not, but yeah, I was searching for register, but I think it is linked somehow somewhere. But in any case, we need to add our new command here. So let's add it. Basically, it doesn't matter that much where to add it. Let's maybe add it here. Our magic number. And I think that should be it for our first version, if I didn't make any mistakes, but you know how it is. Let's stop the node and let's try to recompile it. Alright, something is wrong. So yeah, so there's a mistake. Let's compare it, guys. What's wrong? Name, description. We don't have an argument, so it should be fine. The result seems fine. Examples. Yeah, there's no this guy. And this seems fine, I would say. Yeah. Let's see. Yeah, right now it will work, I think. Yeah, so we have it built. So right now, if we start the Bitcoin node again, we should be able to call actually our custom command, which we can, which is amazing. As you can see, we have our two examples, one for CLI and one for remote procedure calls. But let's just call it, not help, but call it. And we have our numbers, so it works. So let's add the argument, which we just have as a multiplier. Here it was a type. Then we say that it's not optional, it's required. Then some kind of description, making magic number even more magical, and it must be positive. We'll add validation in a while. Alright, so we have this guy. Right now we can take it from request. It's first, then we get int, basically. There are various types of integers in this particular case, and here we'll have our validation. So multiplier must be at least 1. If it's less, we will throw JSON RPC error. We have special code for that, and let's say that multiplier must be positive, like that. That's just also uni value. Oh, my ID doesn't like it for whatever reason, but let's ignore it. Here we just have code, standard code for this error, and I think that's it. We need to add one more thing, but let's not add it and show the problem that we are about to have. So let's recompile it. Alright, so let's rerun our node. Right now, if we try to call it, as you can see, we need to give the argument, but we didn't. But it doesn't work because string is expected. We need to register the conversion from string to integer, but also I forgot to give add argument in the examples. But long story short, there is this weird, to be honest, file where basically there is a list of argument conversions for remote procedure calls, and here we must add our own as well. So let's do that. Nothing special here, just some plumbing. Alright, and standardly let's recompile it. And right now we will have it with the argument. Right, I think it's ready. Yeah, and it works. As you can see, we have registered our own remote procedure call with an argument. So that's amazing, but to make it even better, let's add a functional test. So how it works, more or less, we have a test directory, not this one, this one. We have, among other things, functional tests here of all kinds of features, and remote procedure calls are there as well. And it has these files. They have certain conventions since there's a custom test framework. So more or less, that's particularly wrong one. More or less, we have a base class that we inherit from, and it supports things useful in tests. But these tests, they start node processes and they communicate with it using Bitcoin CLI underneath the hood. Let's stop the node because it will be used in the tests. Yeah, so because of how they work, we need to have binaries built beforehand, but we have. One more thing is that even though they are written in Python and don't need to be compiled, they are copied from the source directory to build a directory with the config file, which is somewhere here. As you can see, there are some constants. So for example, if we would want to run those tests from there, you can do this like this: build test functional, and let's say RPC blockchain. Yeah, and as you can see, the node is started and there are a few tests. Yeah, and it has finished. So we will add our own tests for the code that we have written for the new remote procedure call. So going to README, let's add file like that. So new Python file. Let's copy imports and the executable or interpreter declaration, and let's write get. So our class will be getmagicnumber remote procedure called test. We inherit from the Bitcoin test framework. Then we have set test params. Yeah, so clean chain to true. It basically means that the test will not generate new blocks, which will make it faster because we don't need to have any state for the blockchain for our particular test, and we just need to have one Bitcoin node. I don't remember by default how many are started, but we just need to have one. Then we will write test here. That's the method that we need to override, but let's not do this just yet. Let's have it slightly different, just to see that it can be run. So also we need to have that's the test framework requirement. And for other things, we need to do this, make it executable, and we need to trigger this, because if we run this guy, it's not present in the build directory, so we need to trigger this again. It's not compilation, but a few related processes, and right now, as you can see, it runs. So let's write it to actually do something useful. So as we had here, what we are going to do? Let's have a node variable. So we have a few nodes, one in our case, but variable as array of nodes is the class level is accessible. So let's have our own variable. Then let's log that we are testing getMagicNumber with proper arg values, like that, and assert equal. It comes from the Bitcoin course test framework as well. And then on the node, we can call getMagicNumber. All the test framework is set up in a way that all the remote procedure calls we can call them this way by the name on the node object. And we give arguments here, so running for 1 and for 10, for example, just 2 examples. And we can run it again, make sure that, as you can see, it runs. We can actually validate that it will fail. As you can see, it fails with a good stack trace that shows that this assertion is not true, as it should not be. So let's fix it, and here we have 2 examples of proper argument values. We should also validate that there is a validation, basically. So copying from our readme, getMagicNumber validation, and we have special assert that it writes remote procedure call error. Code is -8, as we have in our C++ file. We have this error code -8. Yeah, so testing it here. This was our error message typo. Not this one. Yeah, multiplier. Yeah, typo again. Multiplier must be positive, and here you're giving function reference and argument value. So we will run it for 0 and 1 negative number. Okay, it doesn't work, I guess, because different than here. We actually, oh no, not different. We don't have exclamation mark. Okay, still. Okay, so I think we actually have an exclamation mark. Yeah, and yeah, alright, it must be. Alright, it works. Yeah, but one more thing I want to check. Here we have exclamation mark. Yeah, because it works on the substrings as well. Yeah, that's why. Let's fix it in the README. Actually, why not? Alright, and as you can see, it works. And but one more thing that we can add is to have our new test being run with all other functional tests. So there is a test runner file somewhere there. So let's add our this guy. Let's add it. Test runner base scripts are here. We can add our guy, find file to get the scriptor here, and yeah, then I think yes, we can do this to run all tests, all functional tests. This will take a while, but let's just make sure that our new test is run as well. And that will close our video, which was quite interesting. And we actually did a few quite complex things, as we have modified the Bitcoin core code base, and we actually also have validated both manually that it works and by running automated tests. So that's quite nice actually. Yeah, so let's wait. Alright guys, the tests have passed. It did take a while, a few minutes as you can see, but we should have our own test somewhere. How we have get magic number. Here it is. We have it here, and it was also run here. 1 second. So I think that's it, guys. I will link my more detailed article down below and in the description if you are interested to dig deeper into the Bitcoin core code. But as for today's video, like the video if you liked it, subscribe to the channel, and I see you in the next one. Cheers!